Good day, ladies and gentlemen. Today we are going to solve this question. And the question says there's a vehicle and a pedestrian leave at the same time, one from A and the other from B, to meet one another. The vehicle travels 9 kilometers per hour and the pedestrians are 5 kilometers per hour. At the time of the meeting, the pedestrian gets into the vehicle. It also takes him 2 hours less to return than to come. Then the question is, what is the distance between A and B? Very interesting question, ladies and gentlemen. So we have two mobiles, a pedestrian and the vehicle. So the vehicle is situated at A, and then the pedestrian is situated at the point B, and the two mobiles are separated by the distance from A to B, which is the subject of our question, the question that you want to answer. Now the question says this, that A is moving toward B in that direction with a velocity VA, which is equal to 9 kilometers per hour. And B is moving in opposite direction to A with a velocity VB, which is equal to 5 kilometers per hour. Now the two are going to come across each other, they are going to encounter. And the point of their meeting, I prefer to take it up there. And let me call this point of meeting O. So A is going to travel a distance that I will call dA and reach the point of the meeting, and B is going to travel a distance that I'll call dB and meet with the vehicle. Now obvious, the distance between A and B, the distance A, B will be calculated as the distance to move from A to O, which is dA, plus the distance to move from B to O, which is dB. Now the distance dA, which is the distance covered by the vehicle, will be equal to the velocity of the vehicle times the time. And this time here, T, it is the time to meet at the point O. Now dA will be equal to velocity of the vehicle, which is 9 times T. This is the equation of the distance of the vehicle. In the same manner, the distance covered by the pedestrian, dB, will be given as VB times T, with T again the distance to move from A to B. And you need to see here that the distance T will be exactly the same. Sorry, the time T spent from B to O will be exactly the same as this time spent from A to B. So the distance B covered by the pedestrian will be equal to the velocity of the pedestrian, which is 5 times T. So ladies and gentlemen, we have here the equation for the movement or the distance covered by the pedestrian. Now the distance that separated the two, A and B, the distance AB will be given as dA plus dB, to be 9T plus 5T. The distance DAB will be equals to 14T. Ladies and gentlemen, I have the first equation that I'm gonna call equation 1. Now the question went on to say this, that at the point of the meeting, the pedestrian jumps into the car, into the vehicle, and the vehicle takes him from the point of meeting to the point of departure of B. And it does so in 2 hours less than the time that B spent to reach O. So we need to take that one into consideration. So I'm gonna write down the distance covered by the vehicle from O to B. that distance will be equal to b, and it will be equal to the velocity of the vehicle times the time. But that time, the question says that it is 2 hours less than the time to move from B to O. That time was t, but we are going to minus 2 because the time that the vehicle spent to cover the distance from O to B, it is 2 hours less than the time that the pedestrian has spent to move from B to O. Now, substituting each variable by its value, we are going to have here dB will be equals to VA, which is 9, factor of t minus 2. Then we are going to have dB will be equal to 9 times t, it is 9t. 9 times 2, it is minus 18. This is yet again another equation we have just found. Now, ladies and gentlemen, I'm gonna write the distance covered by the vehicle from A all the way to B. That distance will be equal to AB. It will be the distance covered from A to O, which is DA, plus the distance covered from O to B, which is DB. Now the distance DAB will be equal to DA, it is 9t, plus the distance DB, the distance from O to B, which is 9t, plus 9t minus 18. Then the distance DAB will be equal to 9 plus 9, that's 18, t minus 18. Ladies and gentlemen, I have found the second equation. So that's our co-equation 2. Equation 1, which is 14t, and equation B, which is 18t minus 18. The two equations represent one and same distance. So I'm going to say equation 1 is equals to equation 2. Equation 1, it is 14t, and equation 2, it is 18t minus 18. I'm going to take a 14 and bring in that sign, so I'm going to have here 18t minus 14t, and I'll take minus 18, bring it in this first level equation. I'm going to have 18. So I'm going to have here 18 will be equals to 18t minus 14t, it is 4t. Using this part, I'm going to have 4t will be equals to 18. So t will be equal to 18 all over 4. T will be equal to 4,5 hours. So t, the time. Ladies and gentlemen, we have found the time t, which is the time to move from point A, where the vehicle is originally located, to the point of meeting, which is also the time for that the pedestrian will spend in moving from B to O. Now, having the time, I can now determine the distance that separated the vehicle from the pedestrian. That distance, I can use either this formula to calculate that distance, D, A, B, or the other formula. But I prefer this one here because it's short. So I'm going to have the distance, AB, will be equal to 14t. The distance AB will be equal to 14 times the value of t, which is 4,5. The distance AB will be equal to 14 times 4,5, it is 63 kilometers. Ladies and gentlemen, we have found the distance that separated the pedestrians from the vehicle. Thank you very much for watching this video.